Water is often used as an analogy to electrical voltages, in that a container with a certain level of water which is higher than the level in another container, the water pressure tends to go through connections and charge this container up to the level of this container. But that doesn't happen unless there is no resistance between the containers. If the current travels from this container to this, that is corroding. In order to stop the corrosion, we have to add charges to a third container, and when the level comes up sufficiently, it will stop or reverse the flow of the charges from the corroding container into the other containers. That is how cathodic protection works. Now, our problem is that we are trying to measure corrosion cells along a pipeline, and there are many of them. We don't know where they are. So let's put this into an area where we don't know where it is with respect to the electrical pressure of Earth itself. We then have to try to measure the electrical potential between these containers, and we can't actually put a measurement anywhere but on the Earth itself, which has a different level at each of the coating faults or corrosion cells. So when we make the measurement, do we make it from the bottom of the container and ignore the others, so we can say that this one is low by comparison to this one and by comparison to this one, so is the current sufficient to flow from there to there based on their measurements? Or do we measure it from the actual surface of the ground to the level here, in which case we are saying if that one equals that one, then there is no corrosion. But are we taking the measurement from the bottom of the container, or are we taking it from there? Because they're two different values. In this third corrosion cell, we can see that there's a different measurement from the bottom to the water level in that container and that container and the third container. But we don't know whether we're measuring from that level or from that level. The reason we don't know and can't know is because we can't see it. No, all we can measure in this corrosion cell is the difference in potential between this container and that container with respect to ground level. We can't see if there are any charges or any water in this container at all. We just can't see it. So therefore, this is the difficulty that we're trying to solve when we're attempting to analyse the readings of a close interval potential survey, which is taken over the ground, over an unknown number of corrosion cells, with the potential of the actual pipeline as an average of all of these potentials with respect to the ground itself. That is the problem.